Bismillahirrahmanirrahim. Assalamu alaikum students. I hope you are all fine and must be enjoying with your life. This is our lecture number 23. My dear students, we have done different problems related to assignment model. In last lecture class we discussed about the assignment model problems, and we solved some problems related to the minimization for assigning the different tasks to the different persons or to the different machines. And you already know that we have talked about the Hungarian method, that how we can use that Hungarian method, which involves the different steps and algorithm in order to find the optimal assignment method. So this method consists of the different steps, and if you recall these steps, first of all we will find out what is the minimum value in a particular row, and then we will subtract that minimum value from each respective row, and after this step we will find out the minimum value out of each of the column, and then we will subtract each of this value from the respective column. Then in the third step we will try to assign the different zeros, and a particular procedure is to be adopted in this particular step. That is, we will go on starting from the first row. If there is a single zero in a particular row, we will assign that zero by scaling, and then we will cross the other zeros in the corresponding columns. Similarly, we will move up to the end row, and the same procedure will be adopted. And after checking these rows, we will start checking the different columns. If in a particular column there is a single zero, we will assign that zero, and we will cross other zeros in the respective rows. So this process will be continued until all the zeros in that particular table are either being assigned or they are being crossed. So this step is so important. After this step, if you are able to find the optimal assignment, you can always assign the different jobs to the different persons. But after this step, if you are not being able to find the optimal solution to the assignment problem, then you will have to move to the next step. And in the next step, what we do, we will try to have that sort of method which is known as ticking. We use that ticking. And first of all, we will tick the unassigned row, and if this ticked row has a zero, we will tick the corresponding column, and if this ticked column has an assignment, we will again tick the corresponding row. And after this ticking, what we will do, we will draw the lines on the unticked rows and the ticked columns. After drawing these lines, we will find out the minimum number out of this table through which line is not being passed. That minimum number will be subtracted from each number from which the line is not being passed, and we will add this minimum number at the point of intersection of the horizontal and the vertical lines, and the rest of the numbers in that particular table will remain same. So this is the step which you'll have to follow, and after doing this, again you will be able to assign the different zeros, and again we will start the step 3, that is, we will assign the different zeros right from the first row. And this is a sort of looping, and this looping will be continued until all of your assignments are being optimally made. So this whole process is known as assignment method. Class, up till now we have just discussed the minimization problem. That is, if you are interested in minimization of the cost or minimization of time, if you are going to assign the different jobs or tasks to the different machines or to the different persons. But again, as we discussed in transportation and logarithm, we may also be interested in these assignment methods, that your profit margin may be maximized. So if you are interested in the maximization problem, then there are the different steps which are to be followed in this assignment method, and following that Hungarian method. Now again class, let's have this practical illustration. That is, a shop has 3 jobs and 3 machines, and which job to be assigned to which machine. Again, that is the sort of assignment problem. But in this case, your objective is not the minimization of cost, but you are interested to maximize the profit in job to get all the work done. So again, this is the case of maximization, and assignment problem is solved again by using the same algorithm, that is Hungarian method, which we used in minimization problems. Class, there are 2 methods which can be used for this maximization problem. There will be a difference of only 1 step. The rest of the procedure will remain same throughout this process. In method 1, if you are interested in maximization of some objective, then what we will do, we will multiply the given payoff matrix of profits or gains by -1. So class, you know that first of all you will have to formulate the table in which you may have the different costs for the assignment of the different jobs to the different persons. So that is the case of minimization. If you have a similar sort of table and profit margin is given for assigning the different jobs to the different persons, and we are interested in maximization, so what the first step we will follow, that is, we will multiply all of these profits or gains by -1. So this is the first step. Then use the usual assignment technique to obtain the optimal solution to calculate the total profit or gain referred back to the original payoff matrix. So after this step, first step, that is multiplying by -1 each and every number in a particular table, we will follow the similar steps. That is, again, we will apply the row operation by subtracting the minimum number out of each row from every number of the row, and again we will apply the column operation, that is finding out the minimum number out of each column, and then we will subtract this number from each column, and then again we will check these rows and columns one by one in order to assign the different zeros. And after that, if your optimal solution is not being obtained, we will again use that ticking, and then we may be able to find the optimal solution. So after this first step, the rest of the steps will remain same. So this is the first method. There is another method which we can use for maximization problems, that is subtract each and every entry of payoff matrix of profits and gain from maximum of all the entries of the payoff matrix. So this is again the second method of maximization problem. What we will do, we will find out the maximum number out of the whole matrix, and we will subtract all the other numbers in the matrix from this highest number, and again the rest of the step will remain same, and again for finding out the maximum profit, we will have to refer to the original matrix where the profit margin or the gains for the different assignments to the different machines or job is being given. So class, if you are interested in maximization problems for assignment methods, then these are the 2 methods which we can always follow to find the optimal assignment. Let's have go through this practical example. Now again class, there are 4 machines, that is M1, M2, M3 and M4, and there are 4 jobs, that is J1, J2, J3 and J4. Now this table actually shows the profit margin or gain, that is, if we are going to assign the job 1 to machine 1, there will be a profit of $2 or 2 rupees. Similarly, if we are assigning job 2 to machine 1, there will be a profit of $4. Similarly, if we are assigning this job 4 to machine 4, there will be a profit of $12 or 12 rupees. So this is the profit margin matrix, and what is being required in this particular problem, we'll have to find out which job is to be assigned to which machine to get the maximum profit. So class, let's use the first method in order to solve this particular problem. Let me draw again this particular matrix. Here are the different machines, that is M1, M2, M3 and M4, and there are different jobs, that is J1, J2, J3 and J4. These are the different profit margins, that is 2, 4, 3, 5, 3, 8, 9 and 12, 4, 12, 11 and 10, 3, 18, 15 and 12. This is the matrix class we are given. So as we are interested in the maximization problem, so what we will do in the first method, we will multiply each number or each value in this matrix by -1. So if we multiply each value by -1, the sign of the values of course will be changed, and what we are doing in this particular step, we are multiply each value by -1. So class, the signs of all the values will be changed. This will be -2, -4, -3, -5. This will be -3, -8, -9, -12, -4, -12, -11, -10, then -3, -18, -15, -12. So this is the first step which we will do for the maximization problems. Now class, in the next step again we will have to draw the table by applying the row operation, and in the row operation, you know what we do, we will have to find out the minimum value out of each row. Now let's see the first row. In this first row the minimum value is -5. In second row the minimum value is -12. Third row the minimum value is again -12, and in fourth row the minimum value is -18. So class, in row operation we will subtract this minimum number from each value of this respective matrix, that is the relevant rows. Let me draw again the next table. So class, when we will subtract this particular value -5 from -5, so what will happen? This value will become, the first cell will become -2 minus this minimum value, that is -5. This minus will become plus, so this will become -2 plus 5, and this is equal to 3. So we will put 3 in our first cell. Here this will be 3. Similarly we will subtract this particular value from the rest of the values of this particular row. So it will become 5 minus 4, 1, 2 and 0. One, 2 and 0. Similarly, in the next row the minimum value was -12, so -3 minus -12, it will become positive. So 12 minus 3 will become 9, 12 minus 8 will become 4, So 9, 4, this is equal to 9, this is equal to 4, and again minus 9 plus 12, it will become 3 and 0, that is 3, and this is 0. Similarly, third row, minus 4 plus 12, it will become 8, 0, 1 and 2. 8, 0, 1 and 2. Similarly, for the fourth row, minus 3 plus 18, it will become 15, 18 minus 18, it will become 0. So 15, 0, 15, 0. Next two values will become minus 15 plus 18, 3, minus 12 plus 18, 6. So it will become 3 and 6. 3 and 6. What we do in this particular step, we applied actually the row operation, and next particular step, what we will have to do, we will have to apply the column operation. Now for column operation, we'll have to find out the minimum value out of each column. You can see that the minimum value from the first column is 3. The minimum value from the second column is 0. The minimum value from the third column is 1. The minimum value from the fourth column again is 0. So we will again redraw this matrix. So class, if we subtract this particular minimum value from the first column, it will become 3 minus 3, 0, 9 minus 3, 6, 8 minus 3, 5, and 15 minus 3, 12. Similarly, if we subtract 0 from each value of the second column, it will remain same, that is 1, 4, 0, 0. In third column, the minimum value is 1, so we will subtract 1 from every value from this third column. So it will become 2 minus 1, 1, 3 minus 1, 2, 1 minus 1, 0, 3 minus 1, 2. The minimum value from the fourth column is 0, so this column will remain same. So in this particular step, we actually we have applied column operation. Now after this column operation, now we'll have to assign the different values, or we'll have to assign the zeros actually. So let's start from the first row. Now this is the first row. You can see that there are 2 zeros in the first row, so initially we can leave this row. In the second row, there is a single 0, so we can assign this 0, and we will have to cross the other zeros in the corresponding column. Similarly, third row, there are 2 zeros, so we can leave it. In fourth row, there is a single 0, so we can assign this particular 0, and again we can cross the other zeros in the corresponding columns. So the same process will be repeated column wise. In the first column, you can see there is a single 0, so we can assign this 0, and we will have to cross all the other zeros in the rows. There is a single 0 in this row, but that has already been crossed. In the second column, there are 2 zeros which are either being crossed or being assigned. In third column, you can see that there is a single 0, so we can always assign this particular 0. And now class, you can see that all the zeros have been assigned. So it means we are getting our optimal solution from this particular step, and there is no need to move to the next step. Now what is the optimal assignment here? You can see from this particular table that we'll have to assign job 1 to machine 1, job 4 to machine 2, job 3 to machine 3, and job 2 to machine 4. So this is our optimal assignment, and through this sort of assignment we will be able to maximize our profit actually. And what is the maximum profit? Again, we will have to refer to the original table where the profit margins are given for the different assignments. So J1 to M1, now this is our original table, and you can see that J1 to M1 assignment have the profit of $2 or 2 rupees. So this is $2 for this particular assignment. Then J4 to M2, if you refer again that particular table, J4 to M2, this is the cell, and there is the profit of $12 for this particular assignment. So we will write here the $12. Then job 3 to M3, job 3 to M3, this value, that is 11. So this is $11. And job 2 to M4, now again job 2 to M4, this is the value which is $18. So this is $18, and we'll have to add up all of these values. 12 plus 2, 14, plus 11, 25 plus 18, $43. So class, $43 is our maximum profit actually, and other than this assignment we cannot maximize our profit. So you can see that how we are being able to maximize our profit by assigning the different jobs to the different machines. And again, this problem was related to the maximization case, and we just used the method 1 for maximization. That is, in the very first step what we do, we change the signs of the different values of the profit margin matrix, and the rest of the step you can see are almost same. So this is the method how we can maximize our profit for the assignment related problems. Now again class, let's we have the similar problem, and now we will use the second method. I have told you about the two methods. The second method is that out of this matrix we will have to find out the maximum number, and then we will subtract each value of this matrix from that maximum number. So this is again the first step which will be changed. So let's do again this problem by using this second method. So let me draw again this particular matrix. Again class, the profit margins are given. I am rewriting this matrix. Now class, this is again the same matrix, that is there are the four machines, M1, M2, M3 and M4, there are 4 jobs, J1, J2, J3, J4. The profit margin for the assignment of the different jobs to the different machines has been given in this particular matrix. Now we are interested to assign the different jobs to the machines in a manner that we are able to maximize our profit. So now we will use the second method, and the second method is that we will have to find out the maximum number out of all of these values of this matrix. So you can see that what is the maximum number. This number is maximum number, that is 18. So we will subtract all the values from this value of 18. So let's make this matrix again by incorporating this particular operation. Now class, 18 minus 2 will become 16, 18 minus 4, 14, 18 minus 3, 15, 18 minus 5, 13. So what we are doing, we are subtracting each value from this maximum number of 18. Now again 18 minus 3, 15, 18 minus 8, 10, 18 minus 9, 9, 18 minus 12, 6, 18 minus 4, 14, 18 minus 12, 6, 18 minus 11, 7, 18 minus 10, 8, 18 minus 3, 15, 18 minus 18, 0, 18 minus 15, 3, and 18 minus 12, 6. So this is our new matrix, and again from this step onward we will use the same method as we used for the minimization problems. That is, we will have to apply the row operation and then we will have to apply the column operation. So let's apply the row operation first to this particular matrix. Now first of all we will apply row operation. Now class, in this particular row the minimum number is 13. In this particular row the minimum number is 6. In third row the minimum number is 6. In fourth row the minimum number is 0. So let me subtract this particular number from the respective rows. So the first row will become 16 minus 13, 3, 1, 2 and 0, 3, 1, 2 and 0, that is 3, 1, 2 and 0. Similarly the minimum number in second row is 6. So if we subtract this 6 from each number of this row, this will become 15 minus 6, that is 9, 9, 4, 3 and 0. Again 9, 4, 3 and 0. So this row will become 9, 4, 3 and 0. Similarly in row 3 the minimum number is 6. If we subtract this 6 from this row, it will become 14 minus 6, that is 8, 0, 1 and 2. 8, 0, 1 and 2. Similarly, in fourth row the minimum number is 0, so it will remain same, that is 15,036. 15,036. Now class, now what we have done, we just have applied the row operation, and now what we will do, we will apply a column operation. We'll have to find out again the minimum value from each column, and we'll have to subtract that minimum value from all the values of the respective columns. Now let's apply the column operation. Now class, let's mark the minimum values in the respective columns. In this column the minimum value is 3, in this column the minimum value is 0, in this column the minimum value is 1, and in fourth column the minimum value is 0. So if we subtract 3 from the first column, it will become 0, 9 minus 3 6, 8 minus 3 5, and 15 minus 3 12. Similarly, if we subtract 0 from all the values of second column, this column will not change, that will be same, that is 1 4 0 0. So let's subtract 1 from the third column. 2 minus 1, it will become 1, 3 minus 1 2, 1 minus 1 0, and 3 minus 1 2. In fourth column the minimum value is again 0, so we will subtract this 0 from all the values of fourth column, so it will become 0 minus 0, again same, 0 and 2 and 6. So class, this is the matrix we got after applying the row operation and column operation. And again, because we are interested in maximization of profit, so we have just changed the first step, which was, that is, we find out the maximum number from the matrix available, and then what we did, we subtract all the values of the particular matrix from this maximum number, and again after this particular step we follow the same row operation and then the column operation. Then you must remember that what is the third step, that is, we'll have to assign the different zeros after this column operation, and for that particular step we will have to start from the first row. Now this is the first row, and you can see that there are 2 zeros in this first row, so we will just ignore this particular row initially, and we will move to the second row. Now class, this is the second row, and you can see that there is a single 0 in this particular row, and you know, when there is a single 0 you can always assign that 0, so we will assign that particular 0 by scaling, and we'll also have to cross the other zeros in the corresponding columns. Now that is so important, that you'll have to cross all the other zeros in the corresponding column. Now again, let's move to row number 3. In row number 3 you can see that again there are the 2 zeros, so initially we can leave this third row, and let's move to the row number 4. In row number 4 you can see that there is a single 0, so what we will do, we will assign this single 0, and we will cross the other zeros in the corresponding columns. So we will cross this one here. Now we have completed this particular operation row wise, and we will have to complete again this process for the different columns. So let's start from the first column. In the first column you can see that there is a single 0, so whenever there is a single 0 in a column, you can always assign it. So you can assign it by scaling this particular 0, and again if there are other zeros in this particular row, that is the corresponding row of this assigned 0, we'll have to cross down those zeros. But in this particular row you can see there's a single 0 which has already been crossed, so we can just leave it. Now the next move is that we will have to check down the next column, that is second column. You can see that in the second column there is no 0 spared. There are 2 zeros from which one is already assigned, the other one is crossed. So again we will leave this column, move to the third column. In third column again you can see that there is a single 0, so we can always assign this particular 0, and you can see that there is no other 0 in the respective column. There is a 0 but that has already been crossed. Again fourth column is already being filled. There are 2 zeros, one is already assigned and the other one is already crossed. So we have just completed this particular operation column wise also. So after this method, students, you always know that we'll have to find out that whether we are being able to assign the different jobs to the different machines or not. As you can see from this particular matrix, that there are the 4 different assignments of jobs to the 4 different machines. So this table can always give you the optimal assignment plan. And what is that optimal assignment plan? That is usually being made by the relevant 0 assignments we have marked in squares. You can see that this is the square here, and the relevant assignment will be that we will assign job 1 to machine M1. So our optimum assignment is we'll have to assign job 1 to machine 1. The second assignment here in second column is in this particular cell, that is we'll have to assign job 4 to machine 2. So job 4 to machine 2. Similarly, in the third row you can see another assignment, and again if you see that we can assign the job 3 to the machine 3. So our third assignment is we can assign job 3 to machine 3. In fourth column you can see another assignment, that is we can assign job 2 to machine 4. So job 2 to machine 4. Again students, in these sort of problems we are assuming that any particular job can be assigned to only a particular machine, and the other way is also true that no more than one machine can be assigned a single job. So this is the assumption of this particular problems. So actually in this problem we were interested to maximize our profit. To find out the maximum profit, again students will have to refer back to the original table. That is, we'll have to see that what was the profit margin for assigning the job 1 to machine 1. So if you refer to the original table, you can see that the profit margin for assigning job 1 to machine 1 is 2. So this will be $2 here for this particular assignment. $2. Then job 4 to M2. Again job 4 to M2, that will have the profit margin of $12. So this value will be $12. Then job 3 to M3. You can see job 3 to M3, this has the profit margin of 11. Profit margin of $11. Then job 2 to M4. Job 2 to M4, the profit margin is 18 here. So let's write $18 here. So if we add down all of these profits, 12 plus 2, 14, 14 plus 11, 25, 25 plus 18, $43. So again class, this is our maximum profit. So we cannot have any other alternative plan of assignment through which we can have the greater profit than this particular value of $43. So this is the procedure which may be used in order to maximize the profit if we are facing that assignment related problems. And students, we have used two different methods for this similar problem, and you can see that we have the same profit margin. So you can use either of these methods. And again, let me recall that we have used two methods in order to maximize the profit margin in assignment problems. In first methods, what we do, we will change the sign of the profit margins given in the original matrix, and the rest of the procedure will remain same as we did in the minimization case. In second method, what we do, we find out the maximum number out of the given matrix, and then we subtract all of the values of that particular matrix from that maximum number. And after subtracting, again we follow the similar operations, that is the row operation and column operation. Now again, in both of these problems, we are able to find out our optimum solution in step 3. But if there are the situations, if we are not being able to find out the optimal solution in this particular step, then again we'll have to move down that ticking method and drawing the line method and so on, until we are being able to achieve our objective. So let's students, let's do another example, similar example, in order to maximize the profit. So students, let me write another similar problem here in the form of this matrix. Suppose again there are the 4 jobs, that is J2, J3, J4, and again there are 4 machines, that is M1, M2, M3 and M4. Now let me write their relevant profit margins here, that is 2, 5, 6 and 4, then 3, 10, 9 and 12, then 4, 16, 17 and 15, and again 3, 18, 22 and 19. Now again class, there are the 4 different machines, M1, M2, M3, M4, and there are 4 different jobs, J1, J2, J3, J4, and we'll have to assign the different jobs to these different machines in such a way that we are being able to maximize our profit. So again, this is a similar case, that we are interested in the maximization of the profit rather than the minimization of cost. So again, what we can do, if we use that second method, what we'll have to do, we'll have to find out the maximum number out of this particular matrix. And you can see that out of this particular matrix, what is the maximum number? The maximum number is this 22. This is the maximum number. So what we will do, we will subtract all the numbers of this matrix from this particular maximum number. So let's apply this particular operation and redraw this matrix. Now class, 22 minus 2, it will become 20. 22 minus 5, it will become 17. 22 minus 6, it will become 16. 22 minus 4, it will become 18. Similarly, 22 minus 3, it will become 19. 22 minus 10, it will become 12. 22 minus 9, it will become 13. 22 minus 12, it will become 10. 22 minus 4, it will be 18. 22 minus 16, it will be 6. 22 minus 17, it will become 5. 22 minus 15, it will become 7. Then 22 minus 3, it will be 19. 22 minus 18, it will be 4. 22 minus 22, it will be 0. And 22 minus 19, it will be 3. So class, in the first step, we have applied that maximum number operation. That is, we find out the maximum number out of this matrix, and we subtract all the other values and all the values of that particular matrix from this particular number, and so we can get another matrix. And now again we'll have to apply the row operation. The row operation is, that is, in this particular matrix we'll have to find out the minimum value out of each respective row. So let's find out the minimum value from the respective rows. In the first row you can see the minimum value is 16. This is 16. In second row you can see the minimum value is 10, so you can write 10 here. In third row the minimum value out of this row is 5, so this is 5. In fourth row the minimum value is 0, so it will become 0. So in the next step we will again draw this matrix in order to subtract these values from each row. So again we'll have to draw this matrix again. Now class, let's see the previous table, that we'll have to draw minus this 16 from all the values. So 20 minus 16, it will become 4, it will become 1, it will become 0, it will become 2. So it will become 4, 1, 0, 2. 4, 1, 0, 2. So this is our new row. For the second row you can see that if you subtract 10 from this 19, it will become 9, 2, 3 and 0. 9, 2, 3 and 0. 9, 2, 3 and 0. This is our second row. For the third row again, if you subtract 5 from all the values of this particular row, it will become 18 minus 5, that is 13. 6 minus 5, it will be 1. So 13, 1, 0, 2, that is 13, 1, 0, 2. So this is our third row. Again, next fourth row. The fourth row will remain same because we'll have to subtract 0, so it will not make any difference. This fourth row will remain same, that is 19, 4, 0, 3. 19, 4, 0 and 3. So students, in this particular step we have applied that row operation, and again in the next step we'll have to apply the column operation. That is, find out the minimum value out of each column. From this column you can see the minimum value is 4, the minimum value is 1, the minimum value is 0, the minimum value is 0. So again we'll have to redraw this matrix. So let's subtract this value from each column. That is 4 minus 4, it will become 0. 9 minus 4, 5. 13 minus 4, 9. 19 minus 4, it will become 15. Similarly, from the second row, if we subtract 1, it will become 1 minus 1, 0. 2 minus 1, 1. 1 minus 1, 0. 4 minus 1, 3. Third row will remain same. That is 0, 3, 0, 0. And fourth row will also remain same, because we will have to subtract that 0 from each number, so it will not make any difference. 2, 0, 2, 3, 2, 0, 2, 3. So up till now what we have done, we have used that particular step for maximization problems. Then we have applied row operation, and then we applied column operation. Then in the next step we'll have to make the particular assignment. So let's start from the first row. This is our first row. As you can see that in the first row there are more than 1 zeros. So whenever there are more than 1 zeros in any row or column, we will just leave it initially, and we will assign only those rows and columns in which there is only a single zero. So let's move to the second row. In the second row you can see that there is a single zero, so we can always assign this particular zero. So we can assign this particular zero by making this square around this zero. So when we assign this 0, we'll have to cross down all the other zeros in the respective columns. This is the corresponding column, and you can see there is no other 0 in this corresponding column, so we will leave it as such. Now third row, in third row you can see there are 2 zeros, so initially we can leave it. Fourth row, in fourth row again you can see there is a single 0, so we can always make the assignment for this particular 0. So again, when we assign it, we'll have to cross down all the other zeros in the respective columns. So this is a very important step, students. Now the same steps will be repeated column wise. Now let's see the first column. You can see that this is the first column, and there is a single 0 in this particular column. So whenever there is a single 0 in a column or row, you know that we'll have we can assign it. So we can assign this particular 0 by making square around it, and again all the other zeros in the respective rows will be crossed. So we will cross all the other zeros. Now move to the next column. You can see that in the next column there is 1 0 available to which we can make an assignment. Because the other 0 is already been crossed, so we can always make the assignment at this particular 0. So let's assign this particular 0 by making the square around it. So class, we have made this assignment. There is no 0 in the third column, again there is no 0 in the fourth column, and you can see this particular matrix that again we are being able to assign the 4 zeros. And these are the different assignments actually for the different jobs, and you can also see from these particular assignments that one particular job can be assigned to the one unique machine. So again class, in this particular problem we are being able to achieve our objectives in that third step. Suppose if we are not being able to achieve these 4 assignments, then we'll have to move to the next step, in which that ticking is done, and then we draw the lines, and then the relevant numbers are to be subtracted or added at the points of intersection. But in this particular case we are being able to find the optimal solution. As you can see from this matrix that there are the 4 different assignments we can make. Now how we can make the assignments? These squares or the assignments which are actually the assigned zeros will help us to guide that how we can assign the different jobs to different machines. Now you can see students, this job 1 can be assigned to machine M1. So J1 can be assigned to machine M1, Similarly, this particular assignment J4 can be assigned to M2. J4 can be assigned to M2. Similarly, for this particular assignment J2 can be assigned to M3. J2 can be assigned to M3, and similarly for this particular assignment J3 can be assigned to M4. J3 can be assigned to M4. So this is the optimal assignment plan we can have in this particular illustration. And now class, again we'll have to find out that what is the maximum profit if you are able to achieve this optimal plan. For finding out the maximum profit, again we'll have to refer these assignments to our original table in which the values of the profit margins or the gains is given. So if we refer to our original table, this was actually our original table, and let me write the problem here. So you can see that if we assign job 1 to M1, there will be $2 profit. So if we assign job 1 to M1, there will be the profit of $2. If we assign job 4 to M2, $12. Job 4 to M2, $12. Job 2 to M3, job 2 to M3, $16. This is $16. And job 3 to M4, job 3 to M4, $22. $22. So if we add up all of these values, 12 plus 2, 14 plus 16, this will become 30. 30 plus 22 will be equal to $42. Now class, this is the maximum profit This is the maximum profit which we can achieve by using this particular assignment, that is assigning the job 1 to machine 1, job 4 to machine 2, job 2 to machine 3, job 3 to machine 4, and so we can have the profit of $52. There is no other alternative plan for assignment which can have the greater profit than this value of $52. So this is again students, the importance of these techniques, that these techniques always help us to find out the optimal solution, that how we are being able to achieve our objectives, that is the maximization of profit. So students, in today's class we discussed that how we can maximize our profit if we are using that transportation models, and by using that Hungarian method again we can also maximize the profit in these particular situations. Before our today's lecture we have much practice that how we can minimize the cost in order to assign the different jobs to different machines or different persons, and today we solved some real life illustrations that how we are being able to find out the optimal assignments by assigning the different jobs again to the different machines. So this is the strength of this assignment model again, that it always helps the operations managers and the other organizational managers to achieve their predetermined objectives, that is maximization of profit or minimization of cost. So this is all for our today's topic, students, and again I would like to advise you all students that first of all you'll have to memorize or remember the different steps which are being used in these particular methods, because if you don't remember these particular steps, then you will find these questions very confusing. But if you are being able to remember these steps, or initially you can write down these steps in a particular paper and then follow those steps for solving the different problems, then you will feel that you start enjoying these questions. These questions are so interesting, and now you must be feeling that how this particular subject is different from the other subjects because of these tabular techniques and these step-by-step technique we just used especially for this assignment method. So is the importance of different topics of operations management. So I hope that you will make much practice for these questions from any of the book you have, and in the next class, of course, we will discuss some other important related problems. So see you class in the next week. I wish best of luck to all of you, and thank you very much. Khuda Hafiz.